Welcome to one of my videos over surface area. In this video, we're going to talk about a prism and cylinder. So let's look at what we have here. We have prisms are going to be polyhedrons with congruent polygonal bases. Your bases are also going to be parallel. Cylinders, on the other hand, are going to have congruent and parallel circular bases. An altitude is going to be a perpendicular segment that is going to join the planes of the bases. The length of the altitude is going to be the height of this figure. So for example, down here we have, looking at our pentagonal prism, our height is going to be how tall from base to base it is. So looking at it here, and I'm about to go over this in this next section that I read, but in this prism here, we have that our bases are going to be these pentagons. They are congruent and parallel to each other. And then when it comes to a right prism, so this is going back up here, we have a right prism is going to have lateral edges that are going to be altitudes. So a lateral face in a right prism is going to be a rectangle. And so here, once I look at this prism and I see all of my faces, I notice that the only shapes I have are rectangles and pentagons. The rectangles are going to be my lateral faces, and the pentagons will be my bases. So when you look at a prism, if all of the sides are rectangles, then you can determine which ones you want to be your base. When you have two congruent sides, faces that are parallel to each other, that are not rectangles, those should be your bases. And we'll see some examples down below. But to clarify, base does not mean bottom. Okay, moving on, we have an oblique prism. And so an oblique prism is going to be a prism whose edges are not altitudes. The lateral faces of your oblique prism are actually going to be parallelograms. A right cylinder is one whose axis, the segment that is going to be joining the centers of your two circular bases, is going to be your altitude. An oblique cylinder is going to have the axis is not your altitude. Okay, so real quick, I'm going to try my best to show you just a visual of what oblique is talking about, since in these notes we won't really have any examples of them. But what that's saying is it's going to be easier if I draw a cylinder. You're going to have your circular congruent bases, but it's going to be kind of like a slanted version of it, like what I have here. Okay, like I said, it's not perfect, but you get the idea. Your bases are not directly on top of each other. It's been slanted. They are still parallel. They are still congruent, but they're just not going to be straight up and down from each other. It's going to be slanted. All right, let me erase that real quick before we move into our practice problems. Actually, let me go over our formulas real quick. All right, so our formulas that we have here, there's two of them, and they are going to be your lateral and your total surface area formulas. So our lateral, just to clarify, is just going to be everything but the bases. So for example, when I look over here at this pentagon prism, okay, your lateral area would be finding everything that I did not shade in. So everything but those bases. Total surface area should include all of the surfaces. So going into it, P is going to stand for perimeter as you know, but of the base. So you've got to identify your base and then just add up all the sides of it to find your perimeter of it. Then we're going to multiply that by our h. It's the height of the figure, not of the base. So be very careful. Then moving into our surface area, you will notice that they start off the same. It is just your pH. Okay, you start off with your lateral area, and we just are going to add to it the area of the two bases we didn't account for. So capital B stands for area of your base, and we're multiplying by 2 because you should have 2 congruent bases. All right, now let's look at our practice problems. So for these problems here, 1 through 7, we are asked to find the lateral and total surface area of the following figures. I'm going to start off by mentioning that in figure 1 here, we actually are going to skip over lateral because unless they specify which 2 sides they want to be your bases, it is going to kind of change up depending on what you're using. So I will tell you how I start these problems. In my opinion, a really good way to start these problems is to highlight your bases. It will help you kind of key in on what you need to be using to find P, your perimeter of your base. B, obviously knowing what is the shape to find the area of the base, and as well as your H. Your H, the reason I do this is it's going to go from base to base. So I look at my 2 highlighters and I see how far apart are they. Now, as I mentioned for number 1 here, since this is going to be a rectangular prism, we're going to just find our surface area. And so for that, I'm going to just pick which 2 I want to be my bases. And so I'm going to use the top and the bottom here. I'm going to just kind of shade those in a little bit. And now let's begin. So starting off, we've got our P, perimeter of our base. So since it is a rectangle, I am just going to do 2 times 10 plus 2 times 8. Okay, 2 times length plus 2 times our width is going to give us our perimeter. And so here I'm just going to get 20 plus 16, which will give me 36. Then moving into my H, like I said, the highlighting is very helpful for this part because I'm looking from highlighter to highlighter. How far apart are these 2? And they're going to tell me that that is 2. Now the last key thing that I'm going to need here is my B, area of the base. And since this is a rectangle, that formula is going to be length times width or base times height. So 10 times 8 gives me that my area is 80. Once I know all these key things, I can plug into my formula for my surface area. Okay, so we're going to have our pH, so 36 times 2, plus 2 times B. Okay, plugging that in, I should get 72 plus 160 is going to give me 232 for my surface area. And looking at my units, since there are none provided, I'm going to write units squared. And there you have it. That's how you find the surface area of this rectangular prism. To clarify, another way of doing this if you're not using these formulas is to find the area of each one of its faces, add them together, and you should get the exact same 232 units squared that I got using this formula. All right, let's move into number 2. Okay, so they are pretty nice here in these problems here, which they won't always be, is they are telling you exactly what they want their base to be. And so here they did tell me my base is the right triangle. Remember, base doesn't mean top and bottom here, but in this case, that's just the way it is laying. So using my formula, we're going to have our P for perimeter. And that means we need to add up all the sides of our triangle. I currently know that 2 of the sides are 8 and 17, but I am needing to figure out what is the length of this side of that triangle. Since this is a right triangle, I'm just going to, off to the side, use my Pythagorean theorem formula to plug in to find it. So we'll have 8 squared plus our b squared should be equal to 17 squared. When I square that, I get 64 plus my b squared equals to 289. And when I subtract and take the square root, I am going to get the square root of, we'll have 225. Which just should be 15. All right, so that's going to give me my third side of that right triangle so that I can find the perimeter, and that is going to be 40. Okay, moving into my H, my height of this figure from base to base, from highlighter to highlighter, I'm going to notice that that is going to be 20. And then for my capital B area of the base, I have that triangle, that right triangle. So 1/2 base times height is the formula I'm going to use. And so my base and my height, remember, have to be perpendicular. And so I'm looking for that right angle. And so that's going to tell me I'm going to use 8 and 15. So 1/2 of 8 is going to give me 4. 4 times 15 should give me 60 for the area of that base. Now, for this one, I am finding my lateral. Okay, so I'm going to start off with my lateral area is going to be pH. So 40 times 20 is going to give me 800. And we need to include our units squared since this is area. Moving into my second answer, my surface area, I would have my pH, which is that 800, plus 2b, 2 times that 60, which that's just going to give me 120. And when I add them together, I should get 920 units squared. Okay, moving on to number 3. In number 3, they're telling us that our base is an equilateral triangle. So once again, going to highlight that to begin. Okay, so for P, my perimeter, since this is an equilateral triangle, we know that all of our sides are congruent. And so I'm going to take that side length of 6 and multiply by 3 to get 18. My H here is from triangle to triangle. We are going to have a height of 15. And then for my capital B, if you want to use the formula for area of an equilateral triangle, be my guest, you're more than welcome to. If you want a reminder, it is just going to be our s squared root 3 divided by 4, okay, where s is your side length. If you're not using that, you could still use your regular formula. We've got our 1/2, my base, which should be that 6, my side length, times my height, okay. Well, here, if I draw my height, my altitude, it should cut in half that base to get a side length of 3. And so I'm going to redraw this with we'll have my 6, my 3. We also know that this is going to be a 60-degree angle. And then we have that 90. So I can use my ratios. We have this is equal to my 2s. This is equal to my s, since it is opposite of what should be my 30-degree angle. And then for my height here, my altitude, I would have my s root 3, which would make this 3 root 3. Okay, so half of 6 is going to give me 3. 3 times 3 gives me 9, and then we will have that root 3 left over. Remember, the 3 is only going to multiply to the outside number, that half of 6 where I got that 3 from, because the root 3 can only multiply to a radical. Okay, now that we have everything, we can plug in to our lateral formula. We have our 18 times 15. And when you multiply those two together, you should get 270. We'll have our units squared since this is going to be an answer that they were asking us for. And then I'm going to find my surface area by taking my lateral, my 270, and adding my 2 times the area of the base, that 9 root 3. And when I simplify here, I'm going to get 270 plus 18 root 3. And it will be units squared. Okay, so keep in mind when it comes to adding or subtracting a radical, you have to have the same radicand. Here, that 270 does not have a radical attached to it, so we can't actually combine that 270 plus 18. Root 3, it will just stay as us, showing that we're adding them together. All right, moving on to number 4. Okay, and number 4 here, we are going to have a base as a rhombus. So here's going to be my bases. And they are telling you here that those rhombus are going to have a diagonal of 10 and 24. So I'm going to just split this up. I'm going to draw one diagonal here, 24, and then the other diagonal they told me was going to have a length of 10. I'm drawing it down here. So starting off, if we are finding our P, our perimeter, we would need to know the side lengths of our rhombus. Okay, remember all sides are congruent, but I don't know one side, so I can't figure that out yet. But what I can do is, if you remember, your diagonals are going to be perpendicular, okay, in a rhombus, and so it is going to bisect, and so you're going to get a 12 and 5. So I'm going to redraw this. We'll have 12 and 5 here. And that will help us to then find our side length, which should be this C here that we're looking for in our right triangle. So plugging into Pythagorean theorem, we're going to get 5 squared plus 12 squared is going to be equal to our C squared. When we square everything, we're going to get 25 plus 144, which is going to give us the square root, so I can solve for my C. We'll have here 169, which is just going to give me 13. Okay, so going back over here so that we can find our perimeter, I'm going to take the 4 side lengths that I have and multiply by 13 what each side length is. And when I do that, I should get 52. Okay, then we have our H here, which from rhombus to rhombus, base to base, we have 18. It's going to be the height of this 3D figure. And then our capital B, area of the base. If you remember, to find the area of a rhombus, you're going to take 1/2 diagonal 1 times diagonal 2. So 10 times 24. And so half of 10 is going to give me 5. 5 times 24 is going to give me 120 for my area. Plugging in for my lateral, I'm going to take my 52 times 18. And you should get 936 units squared. Okay, and then for your surface area, you start off with your lateral area, that 936, plus we'll have our 2b, 2 times that 120. So 936 plus we'll get 240 here, should give you 1,176 units squared. All right, moving into our second to last problem on the front side here, we have a cylinder. And so I'm going to start off by highlighting my bases, which should be these circles. Plugging into my formula, we would need to know my P, which, remember, P is perimeter. When it comes to a circle, we reference that as circumference. So we would have 2 pi times my radius, which is 5. And that should give you 10 pi. For my classes, we like exact answers only in case you haven't kind of picked up on that. So here we're going to leave it as 10 pi instead of multiplying 10 times 3.14 or 10 times the pi button in a calculator. This will leave us with our exact answers, which we prefer. Then we have our H, which is from circle to circle, base to base. We are going to have my height, my altitude, to be 14. And then capital B, area of the base, should be pi radius squared, so 5 squared, times pi to give me 25 pi. Plugging in for my lateral area, we would have our P, 10 pi, times our H, 14, and you will get 140 pi units squared. Okay, from there we'll have our surface area. It's just going to take that 140 pi plus 2 times my area of the base, that 25 pi. 140 pi plus, here we would get 50 pi, is going to give you 190 pi units squared. All right, last one on the front side. We have another cylinder problem here. So starting off by, we've got highlighting our bases. Well, in the process of highlighting them, I'll notice that I'm not given a radius or a diameter for them. So in order for me to find my P here, I'm going to have to use Pythagorean theorem. All right, because remember here, your height between it should be perpendicular to that base. And so here I can use this diagonal length of 26 in a right triangle to help me find my diameter. So I'm going to use Pythagorean theorem. We've got our 24 squared plus b squared equals to 26 squared. Squaring everything here, we should get 576 plus b squared is going to be equal to 676. When I subtract, I'm going to get my b is going to be equal to, and I'm just kind of doing 2 at 1, the square root of 100, which tells me that my b is going to be 10. Now remember, this here is the diameter. Okay, so since I have the diameter, when it comes to circumference, I can use diameter times pi. So it's just going to be 10 pi. Then going into my height, remember it's that perpendicular distance, that's going to be that 24. Don't get it confused with the 26. And then for my capital B, area of the base, here I do need to figure out what is my radius since I did have my diameter. Well, remember your radius would just be half of your diameter. So that 10 divided by 2 is going to give me a radius of 5. So we'll have 5 squared times pi to get 25 pi. Plugging in for my lateral area, we have our P, so 10 pi times our H, 24. And you should get 240 pi. And we'll have our units squared. I'm going to write it down below. And then plug in for our surface area. We would have that 240 pi plus 2 times our area of the base, that 25 pi, which 2 times 25 gives me 50 pi. And then we would have, adding that to that 240 is going to give me 290 pi units squared. All right, now let's go ahead and flip over to the last 3 problems on the back side. So for number 7 here, we have that we are going to have a regular hexagon as our base. So looking at it, going to highlight them. Okay, so starting off with our P, perimeter of that hexagon. Since we know that the side length is 10, I'm going to multiply that 10 by 6 to get 60. My H here is going to be 25 from base to base. And then for my area of the base, okay, we're going to be plugging into that 1/2 my perimeter, so that's 60, times my apothem. Real quick, I'm going to do some side work down below to find my apothem. So I'm going to draw my lovely right triangle that I get with my apothem. Remember, it uses half my side length, so I'm going to have a 5 here. This is my apothem. And then for this angle here, I can be plugging into that 360 divided by 2n, which my n is 6, so 2 times 6 is going to give me 12. When you divide 360 by 12, you get 30 degrees. Okay, so here I'm going to be using a 30, 60, 90 ratio. Since that's my 30, my S should be equal to 5. My A is going to be an S root 3. And therefore, I know my apothem is going to be 5 root 3. All right, so taking half of 60, I'm going to get 30. 30 times 5 root 3 should give me 150 root 3. And now let's plug in for our lateral. We would have our lateral is our P. So 60 times our H, 25. And that's going to give me 1,500 units squared. Keep in mind, I keep saying units squared, but that's because I actually am not given any units. If they give you units such as inches, yards, centimeters, meters, make sure you are using that and not units. All right, and then lastly, for our surface area, we would take that lateral area and add 2 times the area of the base, that 150 root 3. which that's just going to give us 300 root 3. And so because we have that radical in the second one, but not in the first, I cannot actually combine them together. And so I'm going to be left with 1500 plus 300 root 3 units squared. All right, moving into our second to last problem. All right, in this problem, we have the plane region is revolved, about the line y equals 2 to sweep out a solid revolution. Describe the solid and find its surface area in terms of pi. All right, so let's look and see. We said that we are going to be revolving around the line y equals 2. I'm going to start off by highlighting that line. Okay, so that means just rotating around that. I am going to, obviously, because I'm rotating around, making a full revolution, that's going to be ending up in a base of a circle. And so I should have that same distance all the way around it as I am rotating. And so I'm going to try my best to draw this, but it should just come out to be a circle over here. Well, sorry, to clarify, a cylinder total. And then we're going to have that circular kind of motion over here as well. And so now you can kind of see the cylinder that we're going to be dealing with to find the surface area they asked for. All right, so just to go over a few things to kind of identify them that will help us with our finding surface area. If I look here, here is my center, so I can find my radius is going to have 1, 2. So my radius, just pointing to it, my r is going to be equal to 2. And then from circle to circle, we would have a height of 1, 2, 3, 4, 5. So my h is going to be 5. All right, so now let's find our surface area. They did first ask us to describe the solid. So doing that first, we can describe the solid as a cylinder with a radius, so r of 2, and a height, h, of 5. Okay, so plugging in to find my p, we would have our 2 pi r, so 2, which when I simplify is going to give me 4 pi. We already mentioned that our h here is going to be 5. And then the area of the base here is going to be that pi 2 squared to get 4 pi. All right, so just plugging in for our surface area, we would have our pH, so 4 pi times 5, plus our 2b, 2 times 4 pi. So 4 times 5 is going to give me 20 pi, plus an 8 pi that we get when we multiply our b by 2 is going to end up with a 28 pi for our surface area. Once again, including our units squared. Okay, that's it for number 8. Now let's move into our final problem. This one can be a little confusing for people. So judging by appearances, what is the surface area of the solid pictured? All right, so looking at our solid here, we are going to see that we have a half a cylinder kind of being pictured over in this region. And then we have our rectangular prism over here. So what we can do to start off, because we're asked for surface area, is we can find the surface areas of both of those and add them together. Like I said, there's going to be more to it, but let's start there. So I'm going to start off with my cylinder. Labeling our work so it's easy to find. So for our cylinder here, we would have our P, our perimeter circumference. So looking at my base, my circle, or in this case, it's going to end up being a semicircle. But looking here, I do not have a radius and I don't have a diameter either. So we need to kind of play with some of the information that is provided. Now, what I do see is going to be that this full length is 15 inches, but they do tell us that this portion of it down here is 11 inches. So what I can do to figure out from here to here, which would be my radius, I can say that I would take that 15 minus 11 to get 4. So here we're going to have a radius of 4 inches. So we'll have 2 pi times 4 to give us 8 pi. Then my h here, okay, I know you can't see the other base, but obviously it should be parallel to that. So moving backwards, right? So from here, we're going to be moving backwards this way. We need to figure out what our h is. Well, looking along those lines, here we go, see that that is going to be 6 inches. And then for my area of my base, we'll have that pi radius, so 4 squared, to get 16 pi. All right, so plugging in for our surface area here, we would take that pH, so 8 pi times 6 plus 2b, 2 times 16 pi. And so that 8 times 6 is going to give me 48 pi, plus we'll get 32 pi here, which is going to give me 80 pi. Now, I want to mention that this was said earlier to be a half a cylinder, and so we are going to find our surface area that we actually need, take half of this 80 pi to get 40 pi. All right, so that's it for our cylinder. Now let's focus on our rectangular prism that we have. All right, so I'm going to kind of draw this to give a little bit more of a 3D effect so we can kind of see some bases and stuff. So what I'm going to use as my base, I'm just picking it. Like I had mentioned when we did number 1, I'm going to use this one and the one that it is parallel to. I use these two as my bases. So starting off for our P, we would take 2 times 11 plus 2 times 6. And so 2 times 11 is going to give me 22, plus the 12 I'll get here, I should get 34. For my H here, I'm looking from base to base. How far apart are these two? Well, that's looking to be the diameter of the semicircle I have. And so since I said my radius was 4, I'm doubling that to get here. I would have that 8. And then for my B, area of the base, it's going to be 11 times 6 to give me 66. Now we can plug in for our surface area. For that prism, we would have our pH, so 34 times 8 plus 2b, 2 times 66. Plugging that into our calculator, we are going to get a total of 404. All right, so as I mentioned earlier, we're going to add these two together. We got that 404 plus that 40 pi. But what I left out mentioning until the very end, till now, is that we have to account for, are all these surfaces present from the outside? Can you see all of these surfaces from the outside of the figure? And that's going to be a no. Here, the one I'm shading in right now, this black one here, you're not going to see on the outside of the figure. And so we need to make sure that we are not accounting for that surface when we have our surface area. But we did. When we found the total surface area of our rectangular prism, we accounted for that. And therefore, I need to subtract it out, the area of that rectangle. So I'm going to subtract from it. The area of that rectangle would just be 6 times 8. So that's going to give me 48. So we'll have 404 plus 40 pi minus 48. And so that will simplify to give us, we'll have 356 plus 40 pi inches squared. All right, and there you have your total surface area of this composite 3D figure.